Hopefully the audio is fixed. So check, check. Can you hear me?
Confirmed.
Yeah.
Yep.
All right. Today we're going to be start work on notation, symbols, and syntax. Before we start, any follow-up questions from last week?
Oh my God, teacher, literally yes. I've been thinking about what you said, that math is the underlying structure of the universe. But it got me stuck on a weird question.
Oh, weird questions are usually the best kind of questions, so let's hear it.
Wait, okay, so it's about what you said on structures. Like, 4 apples without the apples is just 4. Or a 4-story building without the building is just 4. So, is 4 like actually real? Like, if a total multiversal collapse happened and literally wiped out every single dimension and atom, would 4 still exist out there in the void? Or is it just like a simulation inside the minds of conscious beings?
Whoa, Poppy, you're asking questions about philosophy, not math. People have been debating that for millennia. And the answer is for this class, it doesn't matter. Whether numbers are a fundamental truth of the cosmos or just a giant game of pretend we all invented, the rules of abstract algebra work exactly the same way regardless. So we can just leave the existential crisis at the door because today we're focusing on how we actually write those abstractions down. So let me change to a whiteboard to show you. Okay, we have this. Okay, this is not actually a 7. This is just 2 straight lines crashing into each other at an angle. But it's a character, it's a symbol. To get to the idea of 7, we would need something like this. 7 apples. But even this is not quite right because it has apples. Getting to the underlying idea is actually quite difficult.
Teacher, this seems obvious. Why would this be difficult to comprehend?
Oh, it's difficult because in human children, at least, the mind is not fully formed at birth. It takes many years to grow and develop the brain enough to get to that point.
Oh, wait, we actually just read about this. That's totally a Jean Piaget developmental psychology thing, right?
Yes, yes. Alan, you're always one step ahead of me. It is developmental psychology, and it's really one of the biggest screw ups of Earth education. Abstract ideas are introduced to children before their brains can really handle it. It takes years for human children to understand that this shape is a representation of the idea of 7. It's not just black pixels on a screen. For example, some make their 7s like this. Using this, the scribbles we make on the screen are changing, but the underlying idea is still the same.
That's like what we did last week, with the 4 being either an open top or a closed top.
Yeah.
Hey, it could be Roman numerals also. Like this. The
Yeah.
idea is still the same, even if the writing is not.
Or a classic 7-segment digital display. 3 specific LED bars illuminated. Top right, bottom right.
Teacher, what about tally marks? Like this.
Ooh, be careful with tally marks, Doug. Different cultures use different ways. Like when I was teaching in China, they showed me this. This is the way tally marks are used there. I don't have firsthand experience with it, but some of my colleagues have said that in Spanish countries, they use this. That's their tally mark when you're using there. Just like the others, the way we write it doesn't change the underlying idea. Yes, Noah, you wanted to add something? Yes, excellent point, Noah. This is just another way to write it. Let me add one more. Let's do. Okay, this does not mean that 3 plus 4 results in 7. And it's not that 3 plus 4 changes into 7. It's that this series of pixels on the screen is 7. It's a different series of lines, but it's the same idea, the exact same idea. It's not a transformation, it's an equivalence. So let's clear this. Okay. Natural next question. If the way we write doesn't change the idea, is there a writing method that does change the underlying idea?
I'm not sure I understand, but do you mean like putting a 2 here, like this? Now the 7 is not 7 anymore. It's 70.
Or we
Yeah,
could add a 2 like this, and that changes to 49.
yeah, spot on. Yes. Can anyone think of other ways?
Adding a dot in front will change it from 7 to 7/10.
Oh, and if there is the decimal, then we can add a line above like this to show repeating, and it becomes 7/9.
Yeah, all correct. There is one last one that I'm specifically thinking of. Let's show.
Aha!
Ah, okay, we have changed the underlying idea from a +7 to a -7. Let me share my screen and we can look at the same thing in Excel. Okay, so here is Excel. We'll have 7 and -7. And you know what? That's too small to see. So let's zoom that into there. And now we can select that and change to currency. And we see the currency for the negative value now has parentheses on either side.
I have seen this before, and it always reminds me of the curves when I dig a hole. If a number is in a hole, that means it is down underneath ground level.
Yeah, exactly right. Some games where you're keeping score on pencil and paper will use that exact system. They'll write the number down and put a circle around it to mean in the hole. And in the hole is an idiom meaning negative. Excel can't put a circle around a number, but the two parentheses on each side do kind of look like the edges of a hole.
Teacher, in the accounting spreadsheets we use at the office, the format uses red text instead of parentheses.
Oh, yeah, we can do that too. Let's change, let's here. And that would be in, yeah, here. Okay. And now we see the negative value is in red.
But teacher, it's doing more than just color and shape. What's with the extra zeros?
Oh, Alan, the extra zeros are just because in Earth money, we often keep track of parts of the base unit. And that actually leads me to the next thing. If we do more than just 7, like here, we'll do 7 with 9 zeros after it. And when we change that to money, now we have grouping. There is an extra character in between each of the numbers. And that just spaces them out so it's easier to read.
Oh, that's a lot simpler for me to read. I can just look at it and know how big it is instead of counting the zeros.
Yeah, that's it exactly. Speaking of counting zeros, I can also do this. I'll change to scientific. Now, this still means 7 with 9 zeros after it. And you see it is 7 and 9, and that part in the middle, E plus, that means with 9 zeros after it.
Oh, wait. So it's just a zero counter?
Yeah.
Exponents always felt so counterintuitive to us when we wrote them out as powers of 10. But Excel just makes it look like common sense.
Oh, wait. It's not Excel that does that. 7 times 10 to the power of 9 is the same as 7 E plus 9. So whether or not we're using 10 times to the power of, or we're using E plus, they both mean with this many zeros after it. Let's clear everything. I will show you one more. So different ways that we can write 7. Just a regular 7. We can do Roman numerals, tally marks. We can do 7 as, let's format that. Okay. E7 with no after. and 3 plus 4 is 7.
Interesting. We always learned that 3 plus 4 was a calculation and that it transformed one into the other. But if we're understanding right, it's more like a translation than a calculation. It's the same thing but written as multiple characters instead of just a single character.
Yeah, exactly that. Like we did with the 7, you can do it with or without the crossbar. So the shapes that we draw on the screen, the marks that we make with paper, that will change. But 3 plus 7 written down and 7 is the same thing. It's exactly what you said. It is a translation. It is not an operation. Um, let's hold this for a moment. I want to switch back to the whiteboard to here. Okay, so we have different signs that we can do for these actions. Okay? 3 plus 4, the plus sign operator. But we don't have to use just that character. Just like numbers can be written different ways, the operation signs can be different ways. We can use English words like add, okay? Or we could write out plus. We can go really crazy. We can do it with sigma notation. Okay, all of these are changing the marks that we make. It's rearranging the lines, but the underlying idea is still the same. So if that is for addition, the other thing we can do is for multiplication. Usually the first ones people learn are there. But this sign for multiplication looks a lot like the letter X, and when you get into algebra, that can be confusing. So the other way, when we're typing this, we can use the star operator, and that means multiplication. We can hit just Shift and 8. 8. Shift 8 will make that character, and that means multiplication. The other one we can do, okay, this is for pen and paper. We can use the dot operator. Later on, when we get to matrix multiplication, we'll learn that the dot operator is not really multiplication, but for standard pencil and paper, when you're dealing at algebra level, you can use the dot operator. Then we also have this no operator. If we just put two numbers next to each other, this would make more sense in algebra if we were doing X and Y. No character in between, but it is just implied that there's multiplication. We can't exactly do that here because 3 next to 4 would be the number 34, but in parentheses, there's no operator there, and it's assumed to be multiplication. Moving up from multiplication, we have this. Okay? We can put the number up higher and like in the corner. We can't really type the the exponent on the top right using a keyboard. So here we use shifted 6 to mean the same thing. Related to that, you can use pencil and paper method to do this Kunth up arrow notation, which could be an entire lesson by itself. We could also, one of the up and coming ones that more and more people are using here, triangle of power. And I'm running out of room, but in computer programming, exponents are just repeated multiplication. So we just use the multiplication sign multiple times to show that it is repeated multiplication. So those are the basic operations, and we can see each one has different ways to write it. So let's brainstorm for a moment. What characters do you know that also show an action?
Well, obviously, minus and divide. Those are just the opposite to add and multiply.
Yeah, right. And
Divide has more than one way. Like I could do the Gazenta sign.
the what?
like in 4 gesundte 8 twice.
Poppy, I don't think that you know what? Let's just move on.
What about modular division? I know that this character usually means percentage, but in between two numbers it means the remainder when dividing.
Yeah, good idea.
For computer programming, there is also string concatenation. 2 vertical lines.
Yeah, that's another operator that we can do on two numbers. Let's try and go away from computer programming, try and get back into mathematics. Anyone else have ideas?
Teacher, what about factorial? Does it count? It's for just one number and not between two numbers.
Yeah, for what we're doing in this class, I would say yes.
Hang on. If that's the case, then that opens up a lot of other symbols. Floor,
Yeah,
absolute value,
right.
root,
Oh, very
natural
good.
log.
Yeah. And all of these are just different ways that we write the action. There's different actions that we can take, and these just write them down. But let's step it up just a bit. Up until this point, we have been doing operations that take two numbers, or, like Doug pointed out with factorial, an operation that takes just one number. Can anyone think of operations that take three numbers?
Average? The average of 1, 2, and 3 is 2. But that's not for three numbers exactly. Average could be however many numbers I want.
We
Yeah.
were just thinking the same thing for the maximum function. The
Mhm.
max of 1, 2, 3 is 3, but that can be done for any amount of numbers, not just three numbers.
Yeah, I like the ideas that everyone's throwing out, but like you said, those for any amount of numbers, not just three numbers. Can we think of anything that takes exactly three inputs?
The volume of a cylinder is pi r squared h, and that is 3 inputs.
I would argue that pi is not actually an input, but pi is a number, so yeah, that takes in three numbers. They're all correct. But the important thing is that when we start working with three, we don't have a symbol. We don't have a character. Basically, we've run out of characters to use for operations and have to describe them the long way. To show what I'm talking about, let's go back to the old 3 plus 4. Okay, here, the numbers are on the left and right of the action, and the action is in the middle. These are really the only two places we have around the action character, unless we wanted to do above and, but typing or writing things on a line, if they're in a line, we only have two spaces on either side of the operation. The change is to put the action in front. So let's, there, okay? And now when we write this as plus 3, 4, we're putting the operation before the numbers. This is a system called Polish notation.
Whoa, Polish notation? Are we really allowed to say that? That feels low-key xenophobic.
Oh, no, it's not. It's named after Jan Lukasiewicz. He was a logician from Poland. People couldn't pronounce his family name, so they just designated it by his nationality.
I don't think I am permitted to use the word designated. Reducing a sovereign demographic to a macro-level shorthand is a compliance risk. The Robot Resources Department at work would never sign off on that.
No, it's not an offensive word. It was just a practical compromise. The other name for this is prefix notation, because the operator comes first. Pre. It's an execution style.
Whoa, execution?
I-
Teacher, you can't say that out loud. You're going to get the stream demonetized. You have to say unalive style.
Also, why does the operator get to dominate the numbers by standing in front of them anyway? It feels aggressively patriarchal to demand a single top-down structure for how elements relate to each other.
Okay, look, I'm not here to
Vet?
vet anyone's
No,
opinion. We're
I'm
just-
not going. You can't make me
What?
go.
What did I do now?
Teacher, you said the V word.
The what?
V-E-T.
I didn't mean... Okay, I'm just going to call it prefix notation. Okay, let's move on. Okay, here we saw before how to write with the operations in the middle. Let's show you here. Okay, this is 3 plus 4. If we do it as prefix notation, sum, and then followed by 3 plus 4. Okay, this solves two problems. First, we no longer run out of characters. Any new action we want to do, we no longer need a symbol for it. We can just write out a word. And the second thing it fixes is that we are no longer limited to just two numbers left and right of the character. We can have an action with 3 numbers or 4 or more.
Teacher, if prefix ordering inherently resolves these limitations, what was the justification for implementing the middle operator configuration? It seems highly improbable that the original architects of mathematics would commit such a glaring design oversight.
Yeah, we keep coming back to this. Math was not invented. It was hundreds of people over thousands of years that slowly came together into the system we know now. The operator in the middle actually has its origins in language. English sentences go noun, verb, noun. So it was just convenient to write math the same way. That actually leads into my last point. Let's go here. Okay. These are all the things that change. Okay. Each one of these takes the underlying idea of 7 and changes it into a new number. We also learned operation signs. Okay. These are all characters we do for some kind of action. There's a big problem here. This and this both use the same character. One changes the number, one is an action.
Oh, I get it. So it's like 4 minus 3. That could be either a 4 and a negative 3 smashed together, or it could be positive 4 and positive 3 with a negative operation. That's not the same thing. But using the operator in front way, it becomes more clear. We can do subtract 4, 3, or do add 4 minus 3.
Yeah, exactly it. There's no more ambiguity here. If we use the prefix notation with the action in first followed by the numbers, we're not using the dash symbol. We're using the word subtract. This leaves the dash character to mean only negative numbers. So there's no mix-up. There's no confusion about getting one mixed up with the other. That is it for today. Okay, next week, we're going to go more into different kinds of numbers. Today, we briefly touched on positive and negative, but we will run through the full list for next week. Any last minute things before we go?
Doug still has not returned. How will he receive the information on the final part of class?
Okay, you know what? I'm recording this and I'm going to upload it to YouTube. Once it's uploaded, I'm just going to email Doug and I will get him to watch the lesson there. That is all for today. See you next week when we go into different number types. Bye-bye,
Ending
everyone.
transmission.
Stay
Bye-bye.
amazing.
All right, see ya.